I'm going to give you 3 minutes. 3 minutes. Anybody want to put it up?
Yeah, I would love to.
I'm going to give it to Mark. I'm going to save the challenge for you.
Can you help me? No, it's a challenge. You're try by yourself. Well, my challenge is not working.
How big? How big is that?
Miss, 1, 2, 3, right? I know how to add in the calculator. I know that. I'm just making sure there's no some of the calculations, settings that messed up. Now it says multiply base and height base. No, multiply. I said it right
Does everybody have Yeah. Use a calculator. Use a calculator.
Well, it's not 21.
It's not 21.
Oh, I thought.
It's not 9 plus 10. It's not 21. You guys remember that?
Oh, we had it right. Don't say nothing.
This is a small enough class where I feel like we can kind of move quickly at our own pace. This is going to be, again, like me saying something quick, then turning it back to you. Us coming back, turning it back to you. Any questions on this? Like where this is coming from? What do you notice about opposite sides? Yeah, that's going to come in later today. Perimeter is just adding. Area is multiplying base and height. Yeah? Cool. Today's lesson is going to be about this idea of using ratios of similarity. Okay? So I'm going to try and open it up. If I told you the ratio of similarity, if I tell you the ratio of similarity is 3, and you use this rectangle, what would be my new rectangle? If I tell you the ratio of similarity is 3, what could you tell me about this new rectangle? Matthew.
I think the perimeter will change.
Yeah, let's get simpler. I want to save perimeter and area for last. Okay, I think that's as simple as you can get. This is going to be bigger. Could you tell me how much bigger?
3 times bigger.
If our ratio of similarity is 3, it's 3 times bigger. So when I say ratio of similarity, what am I really saying?
Scale factor.
Scale factor. This is a fancy way to say scale factor. Okay. Well, now that we know we're talking about scale factor, not only is your shape going to be bigger, could you tell me something about the height? How much is it going to be?
3 times taller.
Wait, what? It's 3 times bigger. So if our original had a height of 3, the new one will be 9. Because what operation is dilation? Good. Well, what would if my old base was how much?
8.
So my new base should be times 3, 24. Now, Matthew's going to have a hypothesis. He's saying, look, my perimeter, the original perimeter is 22. What do you think the new perimeter is going to be?
Different.
How is it going to be different? How? How does the ratio of similarity, how does the scale factor affect perimeter?
It makes it bigger.
How does it make it bigger? Amsad is saying it should be
66.
So what is he doing?
Multiply.
Okay, that's a good hypothesis. What do you think about area? What would that be? Same thing, right? I think a lot of you are going to have that hypothesis. Look, if sides are getting multiplied, well then it stands to reason perimeter just gets multiplied by the scale factor. Area is just going to get multiplied by the scale factor. And I'm going to tell you, one of them is correct and the other one is not. By the end of today's lesson, you'll find out.
Where's Scooby-Doo at?
Scooby-Doo is right there. Scooby-Doo's, I'm staring right at him, Miguel.
Oh.
You're going to have 4 minutes. 4 minutes with your elbow partners to work on just that first problem, investigation 1. It's got 4 parts, A, B, C, D. Can someone remind me, what's a ratio? It's a fraction, which then tells you the scale factor. So you're filling that in. That's what you're going to do. It doesn't matter, so long as you're consistent. 4 minutes. 4 minutes. Try and just try. You got 4 minutes. Worst thing that happens is you get it wrong. Do it in terms of ratios, because you can write different ratios. This is called a proportion. You're saying this ratio is the same as this ratio. I want to know this ratio, 7/2, what does it equal? Is that the same as the other ratio? So do it that way. Do it that way.
Do it. I have no idea what to do. All right. You remember what we did yesterday?
Watch this.
Do it.
I can walk to you like this.
So
Or I can walk to
this
you
7.
like
What is this 7?
It's a 7.
Yeah, but
No. Where does it come from? Where did the 7 come from? 2. All right. So this would be fraction 1. 7 over 2. Now what is this 21? Where did it come from? 6. So it's 21 over 6. Now simplify the fractions.
You show me.
You simplify it.
You show me.
What else do? Alright, I'm gonna do the first one, you're gonna do this one. So I know 7 divided by 2 equals 3.5. Now do this one.
3.
3? You think so?
3 point.
Just do 21 divided by 6.
3.5.
So are these fractions the same?
Yeah.
Are they similar? Are these similar?
Yeah.
find the natural side.
Now what's the scale factor? What's the scale factor? Exactly.
Let me do this.
Plato.
Put a banana bus.
Huh? Yes, it is.
What would this go?
Yes, it is.
So then that's going to be.
How you spell it?
You spell it B-A.
This is on top.
Perfect. Piri piri apopos.
Tell me, type this in the calculator.
Now do C. Let's do C together. You think you can write a different ratio? What is it? Does that equal 3.5? It has to equal 3.5. So just do something times 3.5. 3.5 over 1.
Wow.
Mister, that's an amazing ratio. What about 7 over 2? What about 10.5 over 3?
Can I see that?
You could keep going everywhere.
Mistakes are fine. Seriously. Okay, let's pretend it is right. All right, so let's go over this. I'm gonna call the big one my image, and the little one my original. What does 2 correspond to? Okay, so what if my scale factor is 3? Yeah, this should be 6. Is that what's happening? No. Yeah, so how do we figure out the scale factor? What do you do to figure out scale factor? Divide what though? Because I saw this, everyone in my other class did this. Everyone in my other class did 6 over 2, and they were getting 3. And then they did 21 over 7, and they got 3. Everyone did that.
Because you're supposed to divide the image times the original.
Perfect.
Divide it by the original.
You're supposed to, say it one more time.
You're supposed to divide the image over the original.
Because what we're interested in is similarity. How did we go from the image to the original? You need to compare the image to the original. That's going to tell you, that's the growth rate. It grows at 3.5. Does the width do the same thing? Yeah. If these ratios are equal, what does that tell you about these shapes? They're similar. They're similar. But is this the only ratio you could have? Is this the only scale factor? No. What's the other scale factor? Okay, so let's pause for a second. I just want to tell you, I'm going to answer this question. I don't want to scroll down because it's going to look weird. If you're saying 3.5 is your scale factor, what's happening to the original? Perfect. Is that the only way? Can dilations only? So there has to be another scale factor. It's not going to.
A decimal.
It's going to be a decimal. So let's. Yeah. But when he's saying decimal, he means something else, and that's where we're going to clarify. Look at this. How'd you get 3.5?
Oh, it's
There it is.
reciprocal.
You do the reciprocal. So now we're going to pretend the small one is not the original. The small is the image. The big one is not the image. It's now the original. So when we do it that way, let's take the image 2 and divide it by the corresponding side in the original. Yeah, you get 0.286. Now we're like reversing it. We're working backwards. We're saying, okay, the original's the big one, the image is the little one. So when we go to figure out the scale factor, we do image over original. Now the image is 2, and the corresponding side is 7. So 2 over 7 is how much? 28.6. Yeah. So what's 6 over 21? What's this divided by the... Yeah, it's the same thing.
So can we put that as a ratio?
That is the other ratio. That is the answer to that.
I thought it was like you changed it.
Matthew was taking something.
I wrote something else.
Yes, you did. And I was right the first time.
I'll take a guess.
Mm-hmm. So, in that last question, we're not gonna dig into it deep. We're just gonna mention it real quick. Plato is writing these two ratios. What is he doing wrong? Go ahead, Ashley.
Oh, this one is from that one. I don't know how to explain it, but it's like he has to do the reciprocal for the other one.
Yeah, and we'll frame it this way. I'll tell you what. If Plato says, "Look, I've got this fraction, 21 over 6. What does that have to equal? What's the other ratio need to be?"
3.5.
But what's it got to be? Yeah, it's supposed to be 7 over 2. So what is he doing wrong when he writes 2 over 7? Yeah, he flipped it. Do you see how, like, on top he's got a big number, and on bottom he has a... Then when he goes to write the other ratio, which number has to be on top? The big.
When you switch it.
Yeah. You've got to match it up. If you start with big on top and little on the bottom, then the other ratio has to match. Has to be the big number on top, the little number on the bottom. What he did over here is he reversed it. He did the little 2 on top and the big 7 on the bottom. He's mixing it up.
If you just say that we flipped it.
Yeah.
I just wrote what you
Is that fine? Can I move on? No fue mi intención. How much time do you need for these 3?
10 minutes.
No.
15.
5? Let's go 4. We'll go 4. I originally did 3, but
15 is enough.
4 minutes. 4 minutes.
15 is way more.
Who wants to put one of them up?
Me.
Yeah?
No, I don't know. No.
No?
Do this one. This one's the easiest
Yeah.
one. Just do it.
No.
So you're saying you're going to do... Try that one. I'm curious if we get that.
Damn, I wrote that
I
mad
thought
big.
everyone would get this wrong, and there were a couple students that got that right. No one got that right.
Which one? The middle one?
Yeah.
I'm gonna get it right.
No, you're not.
Wait, am I right? Yeah, I'm right.
Hey, well, you gotta speak something like that. I know you said second grade.
My dad almost in like first or second grade.
Hello. Is that how long have I known you for? Like 7 years, right? Oh, 7 years.
Anybody want to try number 2 or number 3? Oh, yeah. Which one, you gonna do 2 or 3?
I'll do 3.
4
Okay.
divided by 3 equals.
Wait, you talking about the?
You have to divide first and then. Question. Why you did 6 instead of 3 if 3 is what the same as 4? Like the shape.
What are you talking about?
The shape, these parts are equal to each other. You did this one, which is this.
It's supposed to be that. Either way, it's still gonna be the. Hold up.
Because when she did it, she did 2 and 4, which is like the same size. And then she finds out 6. You did 4 and 6. The 6 is basically this, and then here. And then 4 and 3, which is here and here.
Banana bus. Oh wait, hold on. Let me see. Mark, you're doing it wrong.
It's wrong, right?
Yeah.
It's basically 3
6
and
doesn't
4,
correspond to 4. Shut up. Wait.
I'm not even done.
right? So I'm right?
I didn't finish it. What's the point? Oh shit. What? Yeah. Oh shit. Yeah, I fucked up here.
What the hell is that, y'all?
Mister, I messed up on the second one.
You erased it.
I messed up on the second one because I thought.
Yeah, it's all good. It's all good.
So this is right.
The third one is right, right?
Tampoco.
The third one is right.
Yeah. All right. So, let's go over this real quick.
Is that right? I don't know.
Yeah. How the heck did you?
Because
I know you.
This is the answer?
4 corresponds to 3. When you do that.
No, but what you have is good. I'm going to show you how to solve it. All right, let's go over a few things. I'm not going to go super in depth with the last one. If you got x equals 7, that means you're correct. We're not going to go over it. What is this? I don't understand. Why are they doing 4 over 2?
Because that corresponds.
So what is it? What does this ratio tell you? That is the scale factor.
Wait, you trying to say I'm wrong?
No, I'm trying to figure out why you're right.
Oh.
So that's clearly the scale factor. So then, what is she using that scale factor to do? Yeah, she's taking the original base and she's like plugging it in to the scale factor, and she's getting Yeah, the image, x. Does that method make sense? All right, I'm going to erase this work. And then
do 4 divided by 3.
I'm gonna let Rosanna explain this one. Yeah. So she's gonna write, she's gonna talk.
Oh my god. Anyways, so you see how like these two. You see how these two are like the same like spot.
Same spot. This side corresponds.
Yeah, that. Anyways, so we're gonna divide that.
Compare corresponding parts with division.
Then I got 1.3. So then I'm gonna multiply 1.3 times 6, which is.
Can you do that on your calculators? Yeah, and what do you get about it? 7.8, and like, because what's 4 divided by 3 on your calculators? So instead of doing 1.3, do 1.3333333 times 6.
7.888, right?
I don't know. Just type it in. What'd you get?
You know, let me just keep going for a little
Oh. What do you get when you do it that way? Yeah, you get about 8. Like if you keep that decimal repeating. Yeah, you get 7.9. But that's really approaching what number?
8.
Yeah. So take a look.
Actually got 8.
It depends on the calculators. So if all we did was 1.3 times 6, 1.3 times 6, it's saying that new side is supposed to be 7.8. But then Rosanna was like, oh, it's 4 over 3. It's that number. So if I do 1.3 times 6, oh, the calculator is just like rounding up. It's like, oh, it's like 8. Okay? Did anybody solve this another way? How did you do it, Matthew?
So I'll put the 3 on the top, and because I didn't know if x was bigger than 6.
All right, so let's do it that way. So Matthew, where's my pen? I have it.
It's on the. I knew it.
Yeah. So I mean that's correct. Your method works. But for some reason Matthew decided, well, he's going to do 3, something from the shape on the right. Oh, I had that backwards when I was working with you.
Yeah.
I'm an idiot. That's my bad. So he's doing something from the shape on the right, and then what'd you divide that by?
4.
Why 4?
Because that's what it corresponds to.
Yeah. So he's doing like the right compared to the left. Well, what's the other ratio supposed to be? If he uses 3 and 4, well, he's doing right. So what's the other thing from the right? And then what do you know about these ratios? They are the same. They have to be the same. Because that's what a scale factor is. But what a scale factor is saying is when you take something from one shape and compare it to the other, well then the other sides have to behave the same way, have to get multiplied by 2. So over here, we're just saying if I compare 3 and 4, then when I compare corresponding parts, something from the right divided by the corresponding thing from the left, those ratios have to be equal. That's called a proportion. How do you solve proportions? And this is where you do like this crisscross multiplying. So 3 times x is how much? Then you're going to bring down that equal sign. And then you're going to do the other multiplication. Now you're going to do 4 times 6. And what will that give you? Now we're going to solve for x. X equals. So was Rosanna correct? Yeah. Is my way better?
Yeah, her way is way simpler.
Is her way wrong?
Yeah.
No.
Does it?
It's more stuff.
I like that.
The 7.
What'd you say?
If it ain't broke, don't.
My way is not better. Rosanna's way is not better. Whatever works. If it ain't broke, don't fix it. If Rosanna knows how to do it that way, she should do it that way. You should know both. Yeah. How much time do I have left? Like 15 minutes? Yeah. All right, we're doing real good. I'm gonna give you 5 minutes to do this, but please listen right now. Please wait. You have things written on your paper. Please wait. Don't assume. Just do this activity in this order. Right? You have that. Use those things to figure out area and to figure out perimeter. Then pay attention. Like you have a scale factor. Take that scale factor and have it give you the corresponding base. Take that scale factor and have it give you the corresponding height. And then last, use these numbers to tell me area and to tell me perimeter. Don't assume. Just go off of things that you know. I'll give you 5 minutes and then we'll talk.
14.
Yeah.
So the area.
Yes. Take your area and triple it. Take your area. Take your area. Take that. And then times it by 3. Type it into a calculator. What do you get? Type it into a calculator.
62. No, 63.
Is that what happened to area?
Oh.
This is correct. What you have on your paper is right. So, does the area triple? Something else is going on. Yes. Now you can answer that.
It doesn't triple though.
It doesn't. Something else is happening. When Naomi gets back. Okay, if this is 7, how much is that?
Something like 21.
Write it down. If this is 3, how much is that?
9.
Now use these to do that and that. Do you see how that worked? If this is 7, how much is that?
7 times 3.
Use those.
21.
Yeah, use, and then what would that be?
Wait, wouldn't it be 3 times 3?
Yes.
Oh, then 9.
Yes. Okay. If your scale factor is 3, your original is 7, what's the new side going to be? A dilation is going to take the original and it's going to multiply it by that scale factor. So 7 times 3 is going to tell you the new thing. So what would it be? Perfect. Could you tell me what this new height would be?
9.
Perfect. What are you doing to figure that out? Are you dividing? You did 3 and what with 3 to get 9? Good. Okay. Now that you have the new height and the new width, tell me what the area is. Tell me what the perimeter is. You are, yes, good.
Like that's what my grandma.
Answer these questions.
So my grandma is
What?
Why would I need to do that?
It doesn't do that. No, I was just trying to show you. Does the area triple?
The area doesn't triple, but the
Now,
perimeter does.
good. That's a good question. I want you to think about that. Think about what triples. Yeah, what does triple? Where does this 9 come from? Where does that 9 come from?
Okay, but it's different.
Where does the 9 come from?
after you laugh, right?
So the original was 3, and what was your scale factor? Okay, where did that 21 come from? Yeah, the original times what? And what's 3 represent?
So there.
That's going to help you.
Like I learned to be serious, and he just takes me as a joke.
I get it because if
Ask yourself this. The perimeter doesn't triple.
That's not nice.
the perimeter, oh yeah.
There's some other number. There's some other number.
The area doesn't triple.
Yes, I'm sorry. You're right. The area doesn't triple. You're right. All right, let's bring it back. I think everyone's had enough time. So, what's my original area? How do you get the original area? Yeah, base times height. 3 times 7. What's my perimeter? Yeah, if you add up all the sides, 7 and 3, you get 20. Okay. Let me ask you this. Shh. Please watch. Where does this new height of 9? So you take your. Please look. You're going to take your original side of 3 and multiply it by the scale factor. Well, then where's that 21 coming from? The original side times. Okay. So if we use these numbers now, if we use 21 and 9, what's my new area?
180.
Because 21 times 9 is 189, right? 189? Actually, let me do it that way. 21 times 9 equals 189, yeah? Yeah. All right, what's my new perimeter?
66.
Okay. Does the perimeter triple? So, if you use a calculator and you take your original perimeter, you take your new perimeter and you divide it by your original, it tells you that it got how many times bigger? 3. So that, in fact, tripled. That was your original perimeter times the scale factor. Look at how you're getting. Look at how you're getting the new area. What does 21 represent? The original area. I know that you're saying, oh, look, 21 is the base. But 21 was also the original area. It's like if you take your original area and you multiply it by 9, for some reason that gives you 189. Not only is 9 the height, look at your scale factors. How many times does your scale factor show up? You have it here and here. What operation is dilation? What is 3 times 3?
Times 2 is 26.
So to find the new area, you just take the original area and you don't multiply by the scale factor. You multiply by the scale factor. What times itself? What's that called? You multiply by the scale factor squared. Because how many times is that scale factor affecting the shape?
Oh, no, I'm not saying that.
Can you just read this? It's not on your paper. Just look at that for now. Here it is.
Mister, can I go to the nurse?
You're going to hand this in as your exit ticket, all right? Oh, this is the last thing I got.
We're doing the summary together, right?
No. I want a timer, please. Then I don't. The pass is here. Someone's out. I'm fine with you going out, taking a second. I'm fine with that. You just realize I can't stop right now. Answer that first question. What's your scale factor?
4.
Where did 4 come from?
8 divided by 2.
8 over the corresponding side 2. Okay, well, this is your scale factor. How does the scale factor affect the original perimeter? It just multiplies. So it's 14 times your scale factor. Okay? Well, how does it affect your area?
It multiplies it by squared.
Yeah, it's going to multiply it by it squared. Squared. So take your original area and times it by 16. Times it by your scale factor squared. Because the scale factor is stretching out the base and the height. It's 4 times 4.
Wait. Why did you put 8 over 2?
Because that's how you find out. That was my timer. That there's 5 minutes left. All you're going to do for an exit ticket is you have that bottom problem on your sheet. You're going to put your answer on here with your name. So I want for the bottom problem.
So we don't write nothing here.
No. You can do your work there, but for this one, I want to see your scale factor, your image perimeter, and your image area on this exit ticket. As soon as you're done, you can pack it up.
Wait, I was using the other problem.
What? Okay, I'll put it back.
Wait. What?
Wait, we just write the perimeter and the area?
Yeah, it's all I want. And the scale factor. I want the scale factor.
What size is it? This one or this?
Then just put your answers on there. That's it. I just want the answers on there. Yeah.
This is right.
What do you want, the scale factor? What do you want, the scale factor?
Scale factor, the image perimeter, and the image area. The 3 of them. you have all been fantastic today. Thank you. I'm going to ask one more thing. As you leave, just put your calculators back, please.
Yeah, you see, I'm gonna use the aerial.
Yeah. Understandably, that's where it's going to happen. Tomorrow, all we're going to do is practice.
Wait, that's right. Alright, got it.
Yes.
Mister, you may not look right. I got the skills.
Perimeter just gets more
Alright, here you go.
because it's would you yes flattening calculators. Tomorrow all we're going to do is practice. Yeah. Thank